Lakshmi,
Yes, sir.
are you doing other work also except the classes examples only?
Yes, sir.
Where are you trying from? NCRT trying? Are you trying NCRT?
Yes, sir.
Very good, very good. Tejaswini, Latika,
Sir?
are you trying NCRT questions?
Yes, sir.
Along with questions from any other source, are you trying?
No, sir.
But you should try, grab some book which is like concerned for JEE mains and try questions from other sources also.
Yes, sir.
Karthik, Ranju, so now shall we start? So in the previous class, we have done one or two examples and then we have done inverse of a function. So for a function to be invertible, it should be 1, 1 and on 2. All right. If f from A to B, then f inverse will be from B to A. And then I explained you how does this inverse function work. Then I explained you how to find the inverse of a function. And we have done couple of examples of linear by linear and a quadratic with the restricted domain. All right. Then very important point I told you, either inverse, a function and its inverse, either they intersect on the line y equal to x, or sometimes they may also intersect on a line which is perpendicular to y equal to x. Am I correct now? Then we have done an example from NCRT. And now first of all, today I'm going to cover a couple of topics, but these topics are not there in school syllabus. They are only in the JEE syllabus. First topic is even and odd functions. Even and odd functions. So now I distribute the page into two parts. This is even function. These are odd functions. Number one, functions which follow the rule that f of minus x equals to fx. F of minus x equals to fx for every x comma minus x belongs to domain of the function. Domain of the function. Odd functions. Now, that means if I put minus x in place of x, it absorbs that minus. Like for example, fx equals to x square. Fx equals to mod x. Fx equals to cos x. They all are what? They are the examples of which function?
Even.
Examples of even function. Now there comes odd function. So functions which follow the rule f of minus x is minus of fx. That means if I put x as minus x, that minus comes out. Okay, are called are odd functions. For example, fx equals to x cube or x mod x or x plus x to the power 5, this kind of, or sin x or tan x, and there are many more we will discuss in the upcoming examples. Am I correct? So these are called odd functions. These are called even functions. Now, these functions are symmetric about y-axis. These functions are symmetric about y-axis. Here, these functions are symmetric in opposite quadrants. Do you understand the meaning of symmetric in opposite quadrant? Like if I see the graph of x cube, so it will be something like this. Like this. Don't you realize it is symmetric in opposite quadrant? Here, if I see the graph of y equal to x square, the graph is like this. So definitely it look like symmetric about the y-axis. Yes or no? Am I clear?
Yes, sir.
Now, next point. Symmetric. Now see, it is not necessary that like many one and one we have seen. Every function, either it will be a one or it will be many one. Getting my point? But here it is not the case. There can be functions. There can be functions which are neither one, sorry, which are neither even nor odd. For example, like fx equals to x square plus x cube. It is neither an even function nor an odd function. Or fx equals to greatest integer x, or fx equals to log x. So these functions are neither even nor odd functions. Then there can be functions which are even as well as odd. For example, fx equals to 0. Constant function fx equals to 0. This is the only function. But I should not write there can be. There is a function. There is a function which is even as well as odd. And this is the only function which is even as well as odd. That is fx equals to 0. Am I correct? Understood? Now,
Yes, sir.
sorry. Lakshmi, are you saying something? Now, every function can be written as the sum of a even function and a odd function. Every function can be written as the sum of a even function and a odd function. And same rule like we have done in symmetric and skew symmetric functions. That is, fx can be written as fx plus f of minus x upon 2 plus fx minus f of minus x upon 2. Understood? So fx plus f of minus x upon 2 plus fx minus f of minus x upon 2. This is its even part, and this is the odd part. But yes, there is a condition that minus x should also be in the domain of the function. Conditionally, x and minus x both should be in the domain of the function. Time take. Both should be in the domain of the function. Am I clear? Okay, now let's do one or two examples. Check for the function if it is even or odd. First is fx is ln of 1 minus x upon 1 plus x. Second, fx is ln of root 1 plus x square minus x. Yes, do it quick. Yes, quick, please. See, for the first part, fx is ln of 1 minus x upon 1 plus x. If I try to find f of minus x, so for that, what will you do? You will replace x by minus x. So it will become ln of 1 plus x upon 1 minus x. So if I add both of them, fx plus f of minus x, it is ln of 1 minus x upon 1 plus x plus ln of 1 plus x upon 1 minus x. That is ln of 1 minus x into 1 plus x upon 1 plus x into 1 minus x. Now they are cancelled. So it becomes ln 1, that is 0. So fx plus f of minus x is 0. That means fx is minus of f of minus x. That means which kind of function it is? Odd function. Correct? Similarly, check for second one. Now again, if you see, f of minus x will be what? Ln of under root 1 plus x square plus x will come. Now again, if I add both of them, fx plus f of minus x, that would be ln root 1 plus x square minus x plus ln of root 1 plus x square plus x. That is ln of root 1 plus x square minus x into root 1 plus x square plus x. That is ln of 1 plus x square minus x square. X square cancel. Ln 1 which comes out to be 0. And if it is 0, then again function is what? Odd function. Am I correct? Tell me, did you understand it? Now, all right. Now we'll do some miscellaneous questions. In today's class, today's remaining class and tomorrow's class, we will be doing some mixed questions from functions and relations. And after in Wednesday's class, I'll do another topic which is periodic function. All right. So write down a question given fx is cos of ln x. Find the value of fx into fy minus half of f of x upon y plus f of xy. Yes. How will you do it? Quickly, I want quick response. Just be quick. Now see. Cos of ln x fx is given to you. They're asking for its value. See. Cos of ln x, cos of ln y minus half of cos of ln x upon y plus cos of ln xy. Yes or no? This will be cos of ln x, cos of ln y minus half of. Okay, this one I can write cos of ln x minus ln y, and this is cos of ln x plus ln y. Am I correct? Now apply cos c plus cos d here. So the formula is 2 cos c plus d upon 2 means ln x into cos c minus d upon 2, that would be ln y. Now this half and 2 cancel, the remaining entire term also cancels. So you get it 0. So this value goes 0. Am I correct? Understood everybody? Mahesh, understood beta?
हाँ सर.
Very good. Okay, write down another question. See, fx is given to you as 2x minus sin x. And gx is given to you as x to the power 1 by 3. Now, check for 1, 1 and on 2. 1, 1 and on 2 for fx and gx. Yes. Yes, how to do? Quickly do. Let's see. Gautami, you there? Lakshmi? Now see, if I do f dash x will be 2 minus cos x. Now I know cos x lies between minus 1 to 1. So minus cos x also lies in minus 1 to 1. So 2 minus cos x lies in 1 to 3. 1 to 3 means f dash x is always greater than 0. That means fx is always increasing. So always increasing means function is 1, 1. Yes or no? Now it is having fx is 2x. Now x is odd degree polynomial. I'm not considering sin x as of now, but 2x is odd degree polynomial whose range is going to be R. If you add or subtract sin x into it, it won't make any difference because slight value of sin x between minus 1 to 1 won't change the very large value of x. Got it? So range is R. That means it is onto. Now here, if I calculate g dash x, it is 1 by 3 x to the power minus 2 by 3. That is 1 by 3. Can I write it x to x square ki power minus 1 by 3? Now, because of x square, this g dash x is also more than 0. At 0, it can be 0, chalo even, but 0 won't be because it is 1 by x to the power 2 by 3. So since it is more than 0, gx is an increasing function, yes or no? Gx is increasing function means it is 1, 1. Now, if you realize the graph of gx, it will be of this kind, increasing here and increasing like this here. So that also goes from minus infinite to infinite. Range is R. Now the range is R, the function is on 2. So both the functions are bijective functions. Am I clear? Have a look. Now, next question. Find domain of fx equals to 1 upon under root of greatest integer of x square minus greatest integer x minus 6. Yes. Tell me, what is the domain? Just quickly tell me. This is greatest integer function. This box will represent greatest integer function. Now see, for the domain of this function, what do you want? This greatest integer of x square minus greatest integer x minus 6. It should be greater than 0. First of all, this is inside the root, so it should be greater than 0. Secondly, it is greater than equal to 0. Secondly, it is in the denominator. It should not be equal to 0. So the only option left is it should be greater than 0. So I can write it greatest integer x minus 3, greatest integer x plus 2. It should be more than 0. Now the values of x that satisfy it are greatest integer x should be more than 3 or greatest integer x should be less than minus 2. I can write it greatest integer x more than or equal to 4, greatest integer x less than or equal to minus 3. So from there you can conclude x should be more than or equal to 4 or x should be less than or equal to minus 2. So this is the domain. So your x belongs to minus infinite to minus 2 union. Even I should not include minus 2. Minus 2 you should not include. Minus infinite to minus 2 excluding union inclusive of 4 to infinite. This should be your answer. Understood? Any doubt here? Am I clear? Now, question number 4. Let f is given from R to 2 to infinite. Be a function, be a function defined as fx is equals to x square minus 12ax plus 15 minus 2a plus 36a square. Now, if fx is surjective on R, then find the value of a. Then find the value of a. Yes, how to do? Yes, any idea? Now see, your fx is x square minus 12ax plus 36a square plus 15 minus 2a. I am writing them all together and I can make it x minus 6a whole square plus 15 minus 2a. Now, this is a quadratic polynomial of this type. All right, its point of minima is at x equal to 6a and minimum value is 15 minus 2a. Now, if you want it as an onto function, surjective is onto. That means its minimum value 15 minus 2a should be equal to what? 2. Why 2? Because 2 is the minimum point of range. So, for function to be onto, this 15 minus 2a least value should be 2. So 2a equals to 13. So a came 13 upon 2. So a came what? 13 upon 2. Am I correct? Understood, everybody? Got it? Now write down another question. Given gx is x square plus x minus 1 and gof is 4x square minus 10x plus 5. Find the value of f of 5 by 4. Yes, quickly. Now see, Gx is quadratic as well as Goff is quadratic. Gx is quadratic as well as Goff is quadratic. That can happen only if fx is a linear function. Understood? So let fx is ax plus b. Now g of ax plus b, Goff. Goff is what? G of ax plus b. So that would be ax plus b whole square plus ax plus b minus 1. So it is a square x square plus b square plus 2abx plus ax plus b minus 1. So it is a square x square plus 2b plus 1 into ax plus b square plus b minus 1. Am I correct? Now, if I compare it with 4x square minus 10x plus 5. So first of all, what do you get? A square equals to 4 means a can be plus minus 2. Then b square plus b minus 1 is 5. That is b square plus b minus 6 is 0. So that means b plus 3 into b minus 2 is 0. So b came 2 or minus 3. Now 2b plus 1 into a, it should be minus 10. Now tell me, how can you make it minus 10? Getting my point? If I take, let us make a case. If I take a as 2, implies 2b plus 1 will be minus 5. So 2b is minus 4. So b is minus 2, which is not an option anywhere with me. If I take a as minus 2, implies 2b plus 1 will be 5. So 2b is 4, so b is 2. That is the only option you have. So a minus 2 and b is 2. So that means your fx came minus 2x plus 2. In the question, they are asking for f of 5 by 4. So minus of 5 by 2 plus 2. So it is minus 1 by 2. Minus of 1 upon 2. Am I correct? So answer is minus 1 by 2. Well, let's do a next question. Have a look at it. Anybody having any doubt, let me know. Understood, everybody? Now, write down next question. Given f from 0 to 7 to 0 to 70, fx is x cube minus 12x square plus 45x. fx is x cube minus 12x square plus 45x. Check for 1, 1, many 1, on 2 and into. You got it? Check for 1, 1 oblique on 2. Means check for if it is the function is bijective or not. Check the domain. There is a possibility that the overall function is not 1, 1. Getting my point? But that particular interval which they are saying 0 to 7, this function is 1, 1. So you have to take care of that also. Yes. Now see, if I look at fx is x times x square minus 12x plus 45. If you do its d, for this quadratic, if you check d, that is b square 144 minus 4 into 45. That is 144 minus 180, which is certainly less than 0. Means this quadratic is having only one real root, that is x equals to 0. Now, if I differentiate it, f dash x comes out to be 3x square minus 24x plus 45. Let's take 3 common. So it is x square minus 8x plus 15. Am I correct? That is thrice of x minus 3 into x minus 5. Correct? So now I understood the entire case. There are 2 points, 3 and 5, where derivative is 0. So at these points, function will be having a maximum minimum. So the graph can be something like this. Like this. Your domain is from 0 to 7. So now I have to check these certain values. Now what is f of 3? F of 3 is what? See one thing. Your graph is from 0 to 7. So this is the graph of your concern. This and this and then this. Now value at 7 can be anything that we are going to calculate. Got it? Now, first of all, I'll start with f of 3. F of 3 will be 27 minus 108 plus 135. So it is 27 plus 8, 10, 20 plus 27. That is 54. So this value is 3, 54. Now let me calculate f of 7. F of 7 is going to be 7 times 49 minus 84 plus 45. So it is 7 times 49 plus 45. 90, it comes out to be 10. So this value is going to be 70. So value at 7 is going to be 70. Correct? So definitely range of the function is what? 0 to minimum value at 0, 0 to 70. So that means this function is what? Onto function. Now any line drawn parallel to x-axis is definitely going to intersect it at more than 1 point. So it is many one. Many one. Am I clear, everybody? So see, today you guys have made a record of not speaking a single word in the entire class. I kept on shouting, am I ready? I even called you using your names, but you have choose silence. Why? Why are you guys punishing a teacher like this? So anyways, your future is in your hands. So today, first of all, I explained you with the many one, sorry, with the even and odd functions. So the function which follows f of minus x equals to fx is called one function. They are symmetric about y-axis. Then function follows f of minus x is minus fx. They are odd function. They are symmetric in opposite quadrant. In even and odd function, there is an important point that you should remember that f of 0 is always 0. Definitely. Got it? Then we have done some examples on on even odd functions. Then some miscellaneous questions we have done. Many one, on to, into, domain, surjective nature, composition, and a good question over the onto functions. I think I've been able to make you understand everything. Anybody facing any doubt, do let me know quickly. Any issue, anyone? All right, that would be all from my side for today. So hope you had a great session. Thank you so much.